Hey everyone! This is the beginning of a summary series that takes a look at some of the most important topics in Gen Chem. We're going to cover a huge range of material here, but we're going to start small. And in fact, the first couple of videos in this series are really just dealing with some ground rules for how we measure and calculate stuff in science. Pretty soon, we'll move on to things that are more classic chemistry, atoms and molecules and all that. But for now, we're just going to start with the basics. One of the most universal themes across physics, chemistry, biology, and all the other natural sciences is the art of properly measuring and reporting values. Whether you're in a lab making experimental measurements or at your desk working on predicting what might happen in an experiment, the particular way that you handle your numbers really matters here, much more than it might if you were doing calculations in a math class. So here's the deal. When you work with values in this course, you're almost always going to have a quantity and a unit, and you practically always need both of these things in order to have a meaningful value. The number is obviously important, that's what you're measuring or plugging into your calculator, but the number by itself is completely meaningless if you don't also provide a description of what that number relates to, and that extra information comes from the unit. Broadly speaking, units can be almost anything. You could theoretically measure distances and volumes and the number of items in a collection using any sort of system that you want. But hopefully it makes sense that we'd want to have some standard scales to work with if we're going to be making a lot of the same measurements. Chemists in the global community have adopted a set of standard units that cover a lot of the things that we care most about in the physical sciences. This is called the International System of Units, SI for short, based on its name in French, and you can see the basic set here. We're going to do more with these units in a later video, but for now it's mainly useful just to have a starter set that we can work with. You might have also noticed that some of the units listed here come from the metric system. That's going to be a theme going forward. You typically won't see imperial units like pounds or miles or feet in this course, and you may have to get used to using metric units instead if that system is less familiar. There's another thing that will start to pop up right away relating to units in chemistry, and that's the concept of unit prefixes. No matter where you're from, you've probably learned how to measure things differently depending on the size of what's being measured. I'm from the US, so I grew up accustomed to using the English imperial system of units for many things, and when I wanted to measure the length of something, I might measure it in inches if it was pretty small, or feet if it was a little bigger, or yards or miles for distances that were longer still. So I had a completely different unit to use for each range of sizes. And I had to remember that there were 12 inches in a foot, and 3 feet in a yard, and 5,280 feet in a mile, for instance. One of the ways that the metric system is easier is that we don't have to do this. To take the same example, distances are always measured using the same base unit in the metric system, which we call the meter. Meters are good for measuring the dimensions of a room or the height of a person, for instance, but if you wanted to measure the height of a coffee cup, you might use centimeters, or millimeters for something really small, like the thickness of a small stack of paper. And conversely, if we wanted to measure distances between cities, we'd probably do it in kilometers. See what we did here? The base unit is still the same in each of these scenarios, which is pretty handy. We just added a prefix to increase or decrease the scale of our measurement. And here's the other really nice thing about SI units. Those prefixes always mean the same thing, and they always change the scale by the same nice round power of 10. This makes converting between different units really easy, as long as you remember what each of the prefixes mean in relation to their bare unit. And even this isn't that bad. If you look in your chemistry textbook, you might see a really large list of prefixes and their definitions. But in practice, we only use a few of them regularly. Generally speaking, most measurements we make in Gen Chem will use these orders of magnitude, each separated by a factor of 1,000. There's one more thing that we should mention before wrapping up. All the units we've been dealing with in this initial discussion are simple and singular, but there are lots of quantities in our world that are measured as some combination of those simple units. Speed is a measure of the distance covered during a certain amount of time, for instance. And density is a measure of the amount of mass that's packed into a certain amount of space. These are called derived units, and we'll be encountering lots of them in this course. Sometimes, like in these first two examples, we just write the units out as some combination of SI base units, meters per second for speed, and grams per cubic centimeter for density. Other times, the derived unit actually gets its own name and symbol. The most important of these for chemistry are the volume units. The metric liter is actually derived from the definition for milliliter, which is equivalent to 1 cubic centimeter. And meters, of course, are the base SI unit for length. It's important to know that one for sure, but it's also helpful to just appreciate from the start that this sort of scheme can also get really complicated. The SI units for energy are called joules, and they're made up of a pretty complicated mishmash of base units that ultimately comes from some definitions in physics. It's no wonder that scientists wanted to name a new unit so that they could write about energy in shorthand like this. From now on, these basic concepts about units will be baked into our discussions of Gen Chem, and we'll start using and practicing these conventions during the rest of this introductory unit. In the next video, we'll be taking a closer look at the number part of these values in chemistry. See you then.